Today we are looking at section 3.6. Our objective or target is I can solve word problems using systems of equations. Our first example is if 8 pens and 7 pencils cost $3.37, while 5 pens and 11 pencils cost $3.10, how much does each cost? So, first of all, our important information is pens, pencils, and the total cost. Right? So, first of all, our unknown is how much does each cost. So we're going to represent each thing with the variable. So we're going to say let x equal cost of each pen and y equal cost of each pencil. Right? Then the next step is to find equations. Okay? So 8, or the number that you buy times the cost equals how much you spent on each one. So the amount I spent on pens, 8x, plus the amount I spent on pencils, which is represented by 7y, equals $3.37. That's our first equation. Then our second one, we bought 5 pens, so 5 times the cost plus 11 pencils times the cost, and that time we spent $3.10. Right? Now I'm going to solve this system by the elimination or the addition method. It's also called linear combination method. So what I'm going to do is I'm going to multiply the top equation by a 5 and the bottom equation by a -8. And so that's going to give me 40x plus 35y equals $16.85, and -40x minus 88y equals -2480. The next step is add those together. Notice that the x's add up to 0, so I get -53y equals -$7.95. Then the next step is to divide by -53, and so we get y equals 0.15. So looking back up here, we see, well, that's the cost of a pencil. So pencils are 15 cents each, and then to find the pen, we plug that back in. So I'm going to use the first equation, 8x plus 7 times 0.15 equals $3.37. And so then I get 8x plus 105 equals 337. Subtract 105 from both sides, and I get 8x equals $2.32. Divide by 8, and we're going to get x equals 0.29 or 29 cents. So then the question is, how much does each cost? So now you need to answer the question with a sentence. The cost of each pencil is 15 cents, while the cost of each pen is 29 cents. Okay, so you must answer the question in a complete sentence, right? So that's a very, very common type of question. Another common type of question in these word problems are what are plane or current problems, okay? In the plane problems, we talk about airspeed, airspeed represents the speed of the plane, so I'm going to call that P. And we also talk about wind speed. So wind speed is talking about how fast or how hard the wind is blowing. I'm going to represent that with a W. Now, airspeed and wind speed, that's talking about rates, okay? So in these problems, we have the situation where we have what's called a tailwind. And that's where the plane, let's say the plane is flying along, and the wind is pushing the plane. Okay, so that's my plane, and here's the wind pushing it. So it's actually going to go faster than if it was just flying in still air. So P plus W represents the rate with the tailwind. This is called a tailwind because the wind is pushing it. Okay. Then the other important thing is headwind. Well, in this case, the plane's flying along, but the wind is pushing against the plane. So it's slowing it down. So this one was a plus. This one's going to be a minus. So, because the plane's going slower than what it originally was. So that rate is P minus W, or the plane speed minus the wind speed, because the wind's slowing it down. Okay. Then another very similar type of problem are what we call current problems. So this is like the person's paddling up or downstream, and so we represent the rate that the person would paddle in still water as P, and then but the current is either pushing the person or the person is fighting against the current. So that's the rate of the current. So if you're going downstream, then the current is pushing you. So you have the person rowing along plus the current. So they're going faster. So that's a plus because you're adding to the rate. Okay. So P plus C equals represents the rate. And if you're going upstream, that means you're fighting the current. So you're rowing along, row, but the current is pushing against you, so that's slowing you down. So that's minus. So C, or P minus C, represents the rate that you're actually traveling. Then all of these, both the plane and the current problems, use the formula distance equals rate times time. Okay, so here's an example of one with a current. Okay, the problem says Anne can paddle her canoe at 15 miles downstream in 2 hours. The return trip, meaning she's going upstream, will take 3 times as long. What is the rate of the current? Right? So we have downstream and we have upstream. Okay? So first we want to represent the rate. Well, downstream she has the rate she's paddling plus the current. Upstream she has the rate she's paddling minus the current. The time, well, downstream it took her 2 hours, and upstream it took her 3 times as long, so that's going to be 6. And then we have distance, the distance traveled. And both equal 15 miles. So we have 2 times P plus C has to equal 15, and 6 times P minus C also has to equal 15. Right, now what I would do is first probably get rid of this 2 by multiplying the whole thing by half, and get rid of this 6 by multiplying the whole thing by 1/6. So the top one becomes P plus C equals 15 halves, and the bottom one becomes P minus C equals 5 halves. Now notice that these are really cool because now if we just add them together, the p's add up to 0. So it's 2p equals 20 halves, or 2p equals 10, or p equals 5. And that's 5 miles per hour. That's how fast she's pedaling. But the question is, what is the rate of the current, right? So if I just take this back here and plug in for P, I get 5 plus C equals 15 halves. So 5 halves is the same thing as 10 halves. Subtract 10 halves from both sides, so C equals 5 halves. And so I get C equals 2.5. So the answer, remember you have to always write a sentence answer. The complete answer is the current let's say it this way, has a rate of 2.5 miles per hour. And you have to put the units in. It's very, very, very important. Okay? All right, and a third type of problem is the grocer problem, or the mixture problem. A grocer mixed nuts worth $4 per kilogram and raisins worth $3.25 per kilogram to make a 15 kilogram mixture worth $3.60. Okay, so we're going to say let N equal kilograms of nuts and R equals kilograms of raisins. Then N plus R equals 15, because that's how many total kilograms we have. Now that represents the kilograms. Now we want to represent the value. So the value of the nuts is $4, so that's 4N. The value of the raisins is $3.25, so that's $3.25R. And the value of the mixture is $3.60, but how many kilograms of that do we have? It's 15, so we have to multiply that by 15. So our system is N plus R equals 15, and 4N plus 325R equals 54. Now this is an excellent system for substitution. So I'm going to take this one and solve it for N. So that's going to give me N is equal to 15 minus R. And now I'm going to substitute here. So I have 4 times 15 minus R plus 3.25 R equals 54. Distribute. So this is going to be 60 minus 4R plus 3.25R equals 54. This is going to be 60 minus 0.75R equals 54. Negative 0.75R equals, subtract 60 from both sides, equals negative 6. Divide by negative 0.75. And we get R equals 8. So that means it's 8 kilograms of raisins. Now we can come back here to this one and substitute R. N equals 15 minus 8, or N equals 7. Okay? So the question was how many kilograms of nuts were used? So the answer is the grocer used 7 kilograms of nuts to make his mixture of nuts and raisins.